All right, pre-algebra, we are moving on. Last week we talked about the Pythagorean Theorem, which said that a squared plus b squared equals c squared. In other words, the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. That's what the Pythagorean Theorem says. Today we're going to talk about the converse of the Pythagorean Theorem. So before we even jump into what that is, we need to know what is a mathematical converse. And we're not talking about the shoe brand. We're going to find out how to use the converse of the Pythagorean Theorem, and we're going to determine how to tell whether a triangle is a right triangle with just side lengths. So, getting into mathematical converses. A converse is the reverse of an if-then statement. So, here's an example. If it is raining, remember this is the if portion, if it is raining, then the grass is wet. So, the if portion is it's raining. The then portion is the grass is wet. So we're going to take it and we're going to swap the if part and the then part. So when we reverse it, it looks like this. If the grass is wet, then it is raining. So if you think about this converse here, this is our converse. Is it always true? No, not really. Not always true. I can think of a few reasons why. So if grass is wet, that can mean that someone is running a sprinkler or a hose in their yard, or someone dumped a bucket of water or was watering their plants. It doesn't necessarily mean that it is raining if grass is wet. So just to reiterate, the converse or the reversal of a statement is not always true. What is true is the converse of the Pythagorean theorem. So just to backtrack for a second, the Pythagorean theorem says that if a triangle is a right triangle, that's the if part. If it's a right triangle, then a squared plus b squared equals c squared. So the converse, we're going to take those portions of the statement and we're going to flip them around. So the converse says, if a squared plus b squared equals c squared, then a triangle is a right triangle. And just a reminder, once again, a and b here represent the legs of a triangle, and c represents the hypotenuse. What's going to be extremely important today is that we know that the hypotenuse will always be the longest side of a triangle. So if you were given side lengths of 3, 4, and 5, then the hypotenuse would be the 5-unit measurement. Okay, so we're going to test out the converse of the Pythagorean theorem. We're expected to tell whether this triangle with the given side lengths is a right triangle. So you could draw this, you could sketch it, no matter what, that's fine. But the easiest way is to plug it into the Pythagorean theorem. And a reminder, that is leg squared plus the other leg squared is equal to the hypotenuse squared. So in this problem, problem A here, the hypotenuse, or theoretically what it might be, is the longest side of 41 inches. So let's set this up. One of your legs is 9 inches, so 9 squared, plus the other leg, which is 40 inches. So 40 squared, and that's equal to the hypotenuse squared, which is 41. So 41 squared. So from here, it's just a bunch of multiplying and adding. When we square a number, that means the number times itself. So just to illustrate that, this is 9 times 9 plus 40 times 40 equals 41 times 41. And when I do that work, I get 81 plus 1600 equals, and then 41 times 41 is 1681. So if I add the numbers on the left side, I get 1681, and on the right side, I also have that number, 1681. So the way that we can tell if this is a right triangle or not is if the left side equals the right side. Since it does, this is a right triangle. The triangle that has side lengths of 9, 40, and 41 inches is a right triangle. Let's try another one. We're going to see if a triangle with lengths 8 meters, 10 meters, and 12 meters is a right triangle. So we're going to set it up the same way. I know that the hypotenuse, or the longest side of this triangle, is 12 meters. So I know automatically that's going to be my c squared. And then we're going to fill in the legs. 8 squared plus 10 squared. And like before, we're just using order of operations and determining if the left side equals the right side. So this would be 64, 8 squared is 64, plus 10 squared, which is 100, is equal to 12 squared, which is 144. So 64 plus 100 is 164. And on the right side, we have 144. So here's the thing. 164 is greater than 144. They are not equal to each other. So in this instance, a triangle with side lengths of 8 meters, 10 meters, and 12 meters is not a right triangle. And in our next lesson, we're going to see exactly what type of triangle that might be. But for now, all we need to worry about is that this for sure is not a right triangle because a squared plus b squared did not equal c squared. Okay, I've got a word problem here. Carrie has a large triangular piece of fabric that she wants to attach to the ceiling in her bedroom. The sides of the piece of fabric measure 4.8 feet, 6.4 feet, and 8 feet. Is the fabric in the shape of a right triangle? So again, we can do this without drawing. So we know that we have side lengths of 4.8, 6.4, and 8 feet. The longest side, the c, or the hypotenuse, in our Pythagorean theorem is going to be 8. So just like before, a squared plus b squared has to equal c squared in order for this to be a right triangle. Let's fill in what we know. The legs are 4.8 and 6.4. And the longest side is 8. So just carrying out the math, 4.8 squared is 23.04. 6.4 squared is 40.96. And 8 squared is 64. So let's see. So 40.96 plus 23.04 is actually 64. What do you know? So the left side does equal the right side. A squared plus B squared does equal C squared. So yes, it is a right triangle. And that was our lesson for today. We learned how to determine whether 3 side blanks gives you a right triangle or not. So the assignment is going to be lesson 12.2, part 1. So make sure that you check your assignment details for instructions on how to submit. Make sure that you attach a picture of the work that you show. Post in office hours for public questions. And if you have a more private question or you would just like to work with me one-on-one, just send me an email. Next time we will be talking about the more details about the converse of the Pythagorean theorem and how you can tell specifically what type of triangle you're dealing with using the Pythagorean theorem. Have a great day.